Hi, how are you doing? You know, when I was in school and college, I was taught the exact same nonsensical crap and silliness that you were. All the professors that were, of course, just parroting the stuff that they were taught were teaching, really absurd stuff about Mother Nature. Of course, when talking about natura naturans, I'm not literally talking about, of course, a female that we would call Mother Nature, but, none of this, from the premise of a rational mind was in any way possible. It was completely senseless. The fundamental mechanics or clockworks behind Mother Nature or the universe can't be a literal assault and murder upon Occam's razor. I don't know if you know what Occam's razor is, but it can't be by definition. It's completely impossible. Insane asylums, for example, are full of some really incredibly intelligent people. They can literally do like long-form arithmetic while writing on an imaginary chalkboard in the air, and they get accurate results, but they can't think clearly. And of course, Nikola Tesla himself referred to the scientists of his day in the early 1900s as those that could think very, very deeply, but they couldn't think clearly. Specifically regarding radiation, I was taught the same thing that you were. And, we know about alpha, beta, and gamma radiation. And alpha, of course, just is a helium nucleus. And beta is a really abstract, completely bizarre definition, which is slightly nonsensical. Well, actually, it's extremely nonsensical. But it's extremely rational if we get down to it. And gamma radiation, which, of course, is the most dangerous, is nothing other than high-energy light. These are obviously three different forms of energy. Alpha is stopped by a piece of paper. Beta radiation is stopped by a thin sheet of aluminum. And gamma radiation is incredibly penetrative. Only two of these are actual pure or imminently manifest energies, that being beta and gamma. And of course, alpha radiation is merely helium nuclei. And you know this, and this is the stuff that we were taught in school, and that's the accurate part. But let's actually dissect it and actually bring it down to what's easily digestible, so that anybody could actually understand radiation. And by the way, I have several Geiger counters, and I have all sorts of radioactive lenses. They're doped with thorium, and they're actually beta and gamma emitters. And I've got a lot of videos with Geiger counters showing how radioactive stuff is, and I don't think you could buy these in Europe or Canada, for example. I have a piece of duct tape on the end and string, so I could actually hang this up. But this is actually a thin glass tube. You can't see it because of all the light on my face, but it glows a nice, decent green color, and it's full of radioactive gas, and the radiation is bombarding a piece of phosphorus on a strip. And the radiation that's bombarding the phosphorus generates light, so this is no batteries required. The half-life is about 10 years. It's actually technically about 6, but the point where it becomes useless is about 10 years. Anyway, it's a radioactive light. It's not super dangerous, but you wouldn't want to sleep with it on your forehead, and you wouldn't want to break it, and I think you can't get these in most places. But I've always been fascinated by radiation, but I always knew that the explanations that these idiot scientists were giving were nonsensical. So let's actually, I don't know if you know what Cherenkov radiation is, that super eerie blue light that you actually see in the bottom of a nuclear reactor. And the blue light comes from the Doppler effect of beta radiation, which is going faster than the speed of light. And of course, there's no such thing as the speed of light, it's the rate of induction. And the reason no one ever explains to you why it's going faster than the speed of light. There's some actually really crazy quasi-explanations. But anyway, the Doppler effect, like breaking the sound barrier. When an airline breaks a sound barrier, we get a sonic boom. So it's literally a sonic boom of the beta emission from a nuclear reactor. You just do a Google search on Cherenkov radiation, you'll see this super eerie light blue glow that looks really, really dangerous, and of course it is, being emitted from a pool of water. And these dielectric emissions, which is what beta radiation is, it's actually scalar wave emissions, and they're not waves. It's completely ridiculous. And if you do a search on scalar, everything says scalar wave. But a wave, of course, has a frequency. Unlike regular emissions like gamma radiation, which are measurable in frequency and wavelength, scalar, which of course, scalar, by the way, is what Nikola Tesla's death ray actually is. It's a ultra high voltage scalar emission. And the reason why the Doppler effect occurs in the water or other medium also occurs in the air. We actually watch Cherenkov radiation from cosmic rays hitting our atmosphere. The reason why it's causing a Doppler effect, like breaking the sound barrier, except it's breaking the quote-unquote speed of light, which is actually a rate of induction, is because it actually has no transverse component, because light, by definition, is a coaxial circuit. It's longitudinal rarefactions and compressions with corresponding, whether it be linear or circular polarization, electrical magnetic components. It's literally a coaxial circuit. I don't know if you know what the cross-section of a coax cable looks like. You should look it up. I mean, everybody's got coax in their house, but they may not know what the cross-section is. And by the way, a coaxial cable has a dielectric medium in them. And of course, there's also, too, air coax, which carries high amounts of energy for like broadcast radio, for televisions, you know, the huge towers that are broadcasting TV. It's really expensive, but that's diverging off on another topic. But let's actually apply Occam's razor and common sense and irreducible simplicity, because if, as it's been said, if you can't explain it in simple, then you don't really understand it. Beta is nothing other than scalar wave ionizing dielectric scalar emission. Of course, when I say emission, I mean that superficially, because it's not an emission at all. As I said, Tesla's death ray is nothing other than more than an ultra-high voltage scalar energy beam. Beta radiation is a very low energy, typically at 0.5 microvolts of power. Typically it goes about a meter or so in the air. Gamma, of course, is incredibly penetrative. Alpha is stopped by a sheet of paper, which is just a helium nuclei, 2 protons, 2 neutrons. And actually, if we were to reduce down that even further, I'm in complete agreement with all science, all branches of science, and that a free neutron, after 17 minutes or so, you can look this up if you don't believe me, becomes a proton. So everything that we actually call a neutron becomes a proton in its free state. So if all neutrons become protons, then that means there's only one fundamental actual particle, and that of course goes greatly towards reducibility. And I've stated in countless other videos that, and I've thought about this for countless years, actually well over a decade, and come to the irreducible, undeniable conclusion that the fundamental particle of the universe, as we see from galactic jets, or they actually call them astrophysical jets, I call them galactic jets. They're emitting trillions and trillions of tons of hydrogen, which is one proton. The reason for this, they're actually being emitted at the poles of the galactic centers of galaxies. We've got countless images of this. In other words, it's reducibly, as I've said in other videos, the fundamental particle is nothing other than an ultra-high energy, maybe 30 or 100 magnitudes greater than that of gamma, a super high energy form of light. And I've jokingly called it, because it's so accurate and yet funny, called it hard light, because that's what it really is. So, and countless other people, including Indian metaphysicians and Walter Russell and others, they've said that everything is light. And you would think, well, that's very fanciful. Everything is light. It sounds like some sort of quasi-religious BS. But it turns out that it's undeniably an absolute hardcore pillar of the nature of the universe, is that everything is light. And what we call matter is actually light. It's super high energy. It's literally stable light. And when I say stable, I don't mean it ultimately stable, but it is stable. What we think of as stable in our very short lifetimes, of course it lives infinitely more millennia than our lifetimes, but it's ultimately unstable from our limited short little frigging lives. You know, we of course think it to be stable, but all scientists also too agree that there's no such thing as a stable atom or stable matter, and that of course is irreducibly true. So beta radiation is nothing other than low energy scalar emission. And it's not really an emission, it's a perturbation. But it actually has, unlike light, it has no transverse components. This is a fact, by the way, and I've said this in countless videos. Nikola Tesla's death ray is a high voltage scalar emission. We can't call it scalar waves because scalar emissions, and it's not an emission either, it's a perturbation. It has no cycles, it has no frequency. It is measured in volts per second, not frequencies per second. So that's all beta radiation is. So alpha particles are 2 protons and 2 neutrons, a helium nuclei, and ultimately that's irreducible only to one fundamental particle. And gamma radiation is nothing other than electromagnetic radiation in the high scale. Gamma radiation is light. It's a coaxial circuit. It's a high. By the way, the smaller, the shorter the frequency, the higher the energy. It's also true that the smaller the space, the higher the capacitance. Not that we can scale light, from like infrared to gamma, by hand here, but without drawing on a pad or showing on a computer. The larger the volume, human beings have really no fundamental understanding of field modalities, but size is always representative of magnetism. Okay, this is an irreducible fact of the universe. The larger it is, the more that denotes absence of charge or energy. Low energy light has huge volume. Not that infrared light is this big. I'm actually trying to bring things to scale. The smaller it gets, the higher the energy gets. The smaller the space, the higher. Because we think of like a box. A larger box will hold a lot more than a smaller box. Not that this is a box. But Mother Nature's fields work just the opposite, because the size of the box only represents the footprint of magnetism. Because to say magnetism and to say centrifugal divergence and to say force and to say create space is one and the same thing. Magnetism creates space. Magnetism is force by definition. Magnetism is centrifugal divergence. So the more voluminous it is, the more impotent is the energy. Well, the larger it is, the more powerful it is. No. Smaller the space, the higher the capacitance. When it comes to gamma radiation, it's extremely small volume. I couldn't even represent it in my hands relative to infrared. I'd actually have to go to like this from infrared to the tip of a needle to represent gamma, and actually even infinite. But it's infinitely more powerful. There's a reason why gamma radiation, and this is important, and no scientist, and most of them are idiots, has ever said this. When people, well, gamma radiation is dangerous. Well, yeah, but that's a description. What about a definition? Why is it dangerous? Well, scientists will tell you accurately, well, gamma radiation breaks up your DNA structure, it gets into your bone marrow, and it causes all sorts of... But why? Because gamma radiation is not my opinion, it's a fact. It's high energy light. But why is it so dangerous? Gamma radiation is so powerful is that it is literally like quasi-matter. There is a type of fluid. It's called a quasi-fluid, and it's basically like oatmeal and water. It has many countless properties of water, but it has basically all the characteristics of a solid. It is both extremely liquid and also very, very solid. That's kind of the closest analogy I could actually draw to gamma radiation. It is literally quasi-matter. It is light that has such a capacitance, and it's also incredibly small voluminously due to its frequency, which is incredibly, incredibly high, that it acts like it's basically a light bullet. I'm trying to think of the most simplex way to say this so that people could understand it. It's literally a bullet of light. We go outside, of course, UV damages our skin, and of course light of countless frequencies are falling on our face. And, they do damage to our skin. But they stop at our skin. This visible light, and of course we're being hit by more than visible light, that's just only what we can see. It's not that powerful. Whether the blue end of the spectrum, which is more powerful, that's towards the gamma end of the spectrum, but nowhere near close to gamma, but it's towards that end of the spectrum, measured in electron volts is like 1.7 to 2.4. Gamma is infinitely higher than that. Gamma radiation is literally a light bullet, and the reason why it's so destructive, it is such a high energy that it penetrates basically everything, including all human tissue, and it breaks our genetic structure apart. Gamma radiation is literally a bullet of light. Its volume, its frequency volume, is so infinitesimally countless endless magnitudes smaller than visible light, then it penetrates basically everything. I mean, you can stop it with enough lead. I know this. You know, I've got all sorts of radioactive sources. I mean, that's why. But that's all gamma radiation is. It's just high energy light. And the fundamental particle itself, we could call that a type of radiation, but I mean, it's a stable form of radiation. I mean, everything that is made up of matter, which is everything that we have in our universe, is comprised of protons and neutrons, but since we know that all free neutrons become protons, that means there's only one fundamental particle. What about the electron? Nikola Tesla, the greatest minds of science, of electrical genius, okay, I'm stating what they said. They said there's no such thing as a charge-carrying particle, and I've explained it before in countless videos. It would take a long time in another video to do that here, but Nikola Tesla said that, Oliver Heaviside, Eric Dollard, all the greatest geniuses, so there's no such thing as, you know, if you think like electrons are flowing in the power lines in your backyard, you know, then you've been brainwashed very, very profusely. Just as the same as I was tried to be, but I wouldn't fall for it. I was not going to fall for that form of stupidity. I'm like, you know, should I listen to this idiot professor or these idiots writing books talking about charge-carrying particles, i.e. electrons? Or the people that actually knew what the hell electricity was, dielectricity and magnetism, like Nikola Tesla, Dollard, James Clerk Maxwell, Charles Proteus Steinmetz, Oliver. I think I'm going to listen to the people that actually invented the entire electrical network of the world, not to a bunch of fuzzy-haired crackpots with chalk and chalkboard, you know, teaching in university. These people are empty-headed idiots just parroting garbage that they were told to teach. Just because they have a PhD doesn't mean they know how to spontaneously generate intelligent thought. But I mean, that's all these forms of radiation are. Alpha, beta, and gamma. Beta is a low-energy scalar, low-energy, and I hate to call them scalar waves, but that's the only way you could denote them. But scalar waves don't have a wave component, and they're not an emission, it's a perturbation. It's no different than Nikola Tesla's death ray. Of course, the news media wanted to call it a death ray. Nikola Tesla himself also called it a death ray, but it's a scalar beam energy. It's a high-power energy scalar beam. So the distinction between beta and gamma is one has a transverse electrical magnetic component. It's just high energy light. It's a type of quasi-matter. It's literally a bullet of light, gamma radiation, extremely penetrative. And beta radiation, I just got done explaining, I hope with enough analogies to make it clear. And alpha is just a helium nuclei. I wish I was taught stuff that, you know, was like this in school or college, and I wasn't. I was taught BS, convoluted, you know, layered with garbage on top of garbage. Helium nuclei, dielectric ionizing emissions, and also too, this explains, like I said, Cherenkov radiation. The light generated looking into a nuclear reactor, that blue eerie glue emission. That's the light generated by the beta radiation breaking the speed of light. And it's not a speed, it's a rate of induction. It causes a Doppler effect and a bang, if you will, generation of that blue light. And blue light, of course, is always more energetic than red light, for example. Just like, you know, a fighter jet breaking the sound barrier. It creates a crack. Well, that crack is that Cherenkov radiation, as they call it, being generated by the faster than light, which is not a speed, faster than light, scalar emissions from the radioactive pool. That's all beta radiation is. It's low energy. I mean, I completely agree with scientists. I mean, this is an undeniable fact that they'll tell you that beta radiation typically doesn't go any more than a meter or so in the air. And a vacuum is another matter, but in the air and in the, you know, in the water and the radioactive pools. So, anyway, it's easy to sum up radiation, alpha, beta, and gamma. It makes Mother Nature simple. It makes Mother Nature elegant. It makes cosmic mechanics irreducibly simplex. It's perfectly in line with Occam's razor. It falls in line with all observed effects and phenomena of alpha, beta, and gamma. And it makes things simple. So, Thanks so much. I desperately wanted to make this video because I've not made this video about radiation before. Thanks for watching.